This is the Algebra 1 lesson video for Unit 4, Lesson 2, Introduction to Exponential Functions. All right, we've been focusing this unit so far on just exponent rules and their properties. Today we're going to put them together with functions. All right, so it says here, so far in this course, we've concentrated on linear functions, which are characterized by having a constant rate of change. In this lesson, we will more formally introduce the concept of exponential functions. All right, so what we've been doing so far in this course are dealing with linear functions, and those are in slope-intercept form. Y equals mx plus b. These new functions we're going to talk about, exponentials, are of this format. Y equals a times b to the x. Okay, here, a is the starting value. Now, we're also going to refer to this as the y-intercept. B is what we call the growth rate. All right, the growth rate B tells us that the exponential function is increasing or decreasing. If B is greater than 1, then the exponential function is increasing. If B is less than 1, then the function is decreasing. We will see all of that as we go through the notes today. All right, ooh, that's not what I wanted. Okay, here we go. In example 1, let's look at each of the following exponential functions, and we're going to determine the y-intercept and whether it's just going to be an increasing or decreasing function. Okay, so the y-intercept is always the first number that you see. So here the y-intercept is 5. To determine if an exponential function is increasing or decreasing, I look at the growth rate b. So here, b is 4. B is 4, and 4 is bigger than 1. 4 is a big number, so it is going to be increasing. Okay. All right, let's look at b. Same idea. The y-intercept here is the number in front, 0.5. Now, to determine if I'm increasing or decreasing, I look at the b, 1.25. Well, 1.25 is still bigger than 1, so this is an increasing exponential function. All right, this y-intercept here, the number in front is 7. When I look at the growth rate, 0.9, 0.9 is less than 1, so this function is decreasing. Go ahead and try a few of these on your own. You can hit pause if you think you get the idea. If you don't, stick with me and I'll do the next 3 examples. The y-intercept here in D is 8. Now this one's a fraction, so we have to think a little bit. The fraction 2/3 is my growth rate. Because the numerator of this fraction is smaller than the denominator, this fraction is less than 1, and it's going to be decreasing. Okay. I'm going to skip E for a second and go to F, because F is similar to D. The starting value is 56, but again, I have a fraction as my growth rate, and so when I have a fraction as my growth rate, I have to be really careful. 3 is bigger than the numerator. 3 is bigger than 2. So because the numerator is larger than the denominator, this fraction is bigger than 1, which means it's increasing. All right, finally in E, the y-intercept here is 125, and 1.5 is bigger than 1, so this is also an increasing function. Now what we're going to do next in example 2 is we're going to graph an exponential. We're going to see what it looks like so that we can see how it differs from a linear equation. In this graph, we have that the y-intercept is 8. I can get that just from the equation. The growth rate is the second number. It's going to be 2. And because 2 is bigger than 1, my graph is going to be increasing. Now we're going to fill in the table below and sketch a graph for the function. In order to do that, you need to turn on your graphing calculator. All right, so when I go to my graphing calculator, I'm going to go to the y equals, and I'm going to type in the equation that they ask us to. 8 times 2 to the x. Make sure you put the x in the exponent. You have to use the caret key. Okay. Now I'm going to hit graph first so I can see what this picture is going to look like. All right, so I can already tell just by looking at this picture that it's a curved graph. It's not a straight line. To fill out the table that we're going to do right here, I'm going to have you to click second graph. That takes takes you to the table. Now from this table, I'm going to be able to fill in the values on my paper. So at -2, I have a y value of 2. Right? At -1, if I keep going back to my table, I'll have 4, then 8, then 16. All right, I'm going to have to move that calculator, but you'll be able to use it on your paper. So 2, 4, 8, 16, 32, 64, and 128. All right, now all you have to do is plot the points, and you should end up with a nice curve, just like you had on your calculator. So -2, 2, -1, 4, 0, 8, 1, 16, and then oh look, 232 does not fit on my graph. That's okay. Okay, so I'm going to sketch this graph here. It actually is going to come up like this and just keep going up forever. That's the shape of an exponential function. It's a curved graph. It starts going up kind of slowly, then all of a sudden it shoots up really fast at the end. All right, so this is summarizing, and then we're going to move forward again. Exponential functions are all about multiplication. All right, we're going to be multiplying by the same number over and over again. If I look at the last example, notice that the growth rate is 2. Well, to get from 2 to 4, I have to multiply by 2. To get from 4 to 8, I multiply by 2 again. 8 times 2 is 16. 16 times 2 is 32, and so on and so on. All right, so the growth rate in your equation is actually a number that you're going to multiply by over and over again. All right, I can also tell by this graph it's increasing. I forgot to point that out because the graph is going up from left to right. Okay, so this is just summarizing that A, this number in front, is the y-intercept, and B, the base or the growth rate, the number in the parentheses, is what you multiply by, the growth rate. Let's sketch another graph here on our paper. You need your calculator again, and we're going to graph 10 times 0.5 to the x. Okay, so let's pull out our calculator. Go here to y equals. We'll type in 10 in parentheses 0.5, the caret to the x. So I'm going to hit graph here. And this time when I graph this function, you should see it's still a curved graph, but it looks like it's going down this time. Go ahead to your table, fill in the points that correspond to those on your paper, and then start plotting the points. I'm going to do the same as well. Right? So from our calculator, I have that at -2, the value is 40. At -1, I have 20. 0 is 10. 1, 5. 2, 2.5. 3, 1.25. And 4, 0.625. All right, before I even graph, I have this question in B right up here. What point will g of 0 represent on the graph? Well, look at my table. We learned function notation here. The x is the number in the parenthesis. So when I look at g of 0, that's the value of 10. Well, 10 we know from looking at the equation there, but we can also plot the point. 0, 10 right here. That is the y-intercept. All right, so let's plot the rest of the points. -2, 40 won't fit on my grid. -1, 20 will. So I'm going to plot -1, 20, 0, 10, 1, 5, 2, 2.5, 3, 1.25, 4.625. So this is the same exponential that you just saw on your calculator. The number that I'm multiplying by each time, that's the question in C, then we'll talk about the picture. The number I'm multiplying by is the growth rate, which happens to be 0.5. That's how I get each number in the table. 40 times 0.5 is 20. 40 times a half is 10. 10 times a half is 5, times a half is 2.5, and so on. How does this graph represent exponential growth or decay? Well, this is a graph of decay. First of all, I can tell because the growth rate of 0.5 is less than 1. I can also tell by looking at the picture because the graph is going down from left to right. All right, excellent. All right, so I've seen a picture of exponential growth. I've seen a picture of exponential decay. It says the equations of exponential functions are relatively easy to determine if you understand this lesson so far. Let's see what we can do in the last exercise. What we're going to be given is a table of values, x, y's, inputs and outputs. We're going to find the equation of the exponential function given the table. All right, so let's start with identifying the y-intercept. The y-intercept always has an x value equal to 0. So when I look here for the x value of 0, my y-intercept is 10. So when I write my equation, I'm going to have a y equals 10 times something to the x. I need to figure out what that growth rate is. Okay, well when I look at my table, it appears that from 10 to 30 and 30 to 90, 90 to 270, I'm going up. So that's going to be an increase. So I know the number in those parentheses has to be greater than 1. Now, it might be easy for you to see that I'm multiplying by 3 here. Okay, 10 times 3 is 30, 30 times 3 is 90, so on and so on. And that is right, that's the growth rate. But if that was hard for you to see, what you can do is you can always take the second number, 30, divided by the first number, 10. That will give you the 3. Same if you took the second divided by the first. 90 divided by 30 is 3. That gives you the growth rate. All right, let's try this last one here. The y-intercept is where, again, x equals 0. So that y-intercept in this problem is 60. So my equation is going to have y equals 60 times some value to the x. When I look at my table, from 60 to 15, 15 to 3.75, I'm going down. So this is going to be decreased, and I know that the blank I'm going to fill in here is going down. It's less than 1. Now this one's pretty hard to figure out how I'm going from value to value. So what I would do is take the second term, 240, and divide it by the first term, 960. Let's put that in our calculator and see what we get. All right, so we'll do 240 divided by 960. I get 0.25, 1/4. Now let's double check that that's right. So if I take the next term, 240 times 0.25, I end up with 60, which is the third term. All right, so those are all good things. That tells me that my growth rate is 0.25, which is going down. All right, that's your lesson video for the intro to exponential functions. There's a practice that you can do where there will be a key and a notes practice on Canvas.